So it's my great pleasure to introduce the panel, and I will introduce the moderator, Lucas Biwald, and he will let the other folks introduce themselves, so he will introduce them. So Lucas is a long-term friend of this conference. He's been at Data by the Bay events, and he founded a company called Crowdflower, which when I was at Cloud, we were one of the earliest customers of Crowdflower, so they pioneered the whole notion of human in the loop, and basically this kind of artificial intelligence, right, when people realize actually we have humans, maybe they're even better than AI, and I think this is becoming even more and more and more important, right? So and now Lucas actually went forward and he found a different company called Weights and Biases, and he blogged about going back to the fundamentals of deep learning and hacking his garage and like building deep learning, like understanding how this works. So I think it's super fitting that we're at the conference which connects data engineering and AI, building tools for engineers to run AI, understand that it actually does what you want. So, and we have a illustrious series of folks who can actually explain how to do it best. So it's all to you, Lucas.
All right, thank you. So I'm not sure I've actually ever moderated a panel before, and I was really excited to do it, especially because 4 of you I consider pretty good friends of mine. I know you well, and one of you was actually really excited to meet. So I actually was hoping I could do the introductions if you don't mind. This is my personal opinion about all of you.
I deny everything.
So Pete is Pete, I think I first met you as a customer of Crowdflower. Great choice. He was he was actually a data scientist at LinkedIn back when they had kind of one of the most forward-thinking data science groups. And then he started a super cool startup called SkipFlag, which kind of helped with knowledge discovery inside companies. And they were very quickly acquired by Workday, which was a super cool, super fast exit. I'm sure your investors were thrilled. And he's now actually writing a book. Supposedly writing a book, I haven't seen it, but I'm really excited to read it about AI and product and how you actually kind of make AI work inside products. He's also a social media celebrity.
Yeah, I think I got you 25 customers.
He got us like 25 customers in just one tweet. We didn't even pay him. He'll be a sponsored. So we have like a ML pundit. And then, so Michelle is also, I know her as a Crowdflower customer, great choice. At Inibon, sorry. I no longer work for Crowdflower, but I can't help myself. So Michelle is actually a senior engineer on one of the coolest projects, Kubeflow, that's gotten an incredible amount of traction in just, I think, like 9 months since the launch. It's, I think, one of the most important projects happening right now in open source and AI. And she has a lot to say about Scala that I'm excited to learn about. So I think really the one Scala expert on our panel today, I think, unless anybody else wants to claim expertise. So Stepan runs Hydrosphere, or CTO of Hydrosphere, which is a super cool ML infrastructure company that helps you kind of store your models and deploy your models and make sure that everything is super reliable. So it's not just a successful company that he funded himself, which is incredibly impressive, incredibly hard to do. It's also a super popular open source project. So incredible achievement there. And so the one person I don't think I've met you, Chris, but I know of you. Pleasure to meet you. So Chris runs pipeline.ai, which was notable to me. I see lots and lots of companies' websites, but your website really stood out to me for its amazing number of high-profile, kind of Fortune 500 customers, and its aggressive use of Comic Sans, which I just thought that combination was spectacular and intriguing. And also a super popular open source project. Is that a good introduction? If you want to add anything, I know less about you. All right. And Richard Socher, I mean, you just saw him talk. I knew him as a startup founder of a really exciting startup. Also, one of the most popular teachers Stanford has ever had. Apparently, he's retired from teaching now, which is your loss. But the videos remain.
They're still online, yeah.
And you should watch them. They're really, really good. I actually learned a lot from your videos. even though I took that class a long time before, but you really updated it well. He's the chief scientist of Salesforce. What you might not know is that Richard is a avid motorcyclist and paraglider. And you should ask him about the time that he tried to do a wheelie on his motorcycle when he first got it.
Please don't ask.
And his Instagram and Facebook feeds are truly, they'll make you feel really bad about yourself. So, all right. So I was excited about this panel. Before I get started, do people have questions they want to ask? I was kind of tweeting it out, but I have a ton of questions. Let me just refer to my notes here for the top questions that I saw. So I actually want to start with Michelle. I'm sorry to do this, but I can't help myself. I was kind of curious about your thoughts on like Scala versus Python when it comes to machine learning and your experiences, since I guess really relevant to the audience here.
Maybe anyone else wants to chime in first. Go ahead.
I think you should start.
All right. So let's see. So my thoughts on Scala. I was introduced to Scala via Spark. So a little bit of background. So I'm an engineer at Google now, working on Kubeflow. But prior to that, I was at a few startups here in San Francisco, building machine learning products on GCP and AWS. And then prior to that, for about a decade, I was a data engineer in the enterprise. So Spark was really important for me. That was kind of my bread and butter before I got into building machine learning products. And so it was a very natural tool to reach for whenever I started at Iddybon using Crowdflower. Like, sure, Spark belongs in this toolkit. I don't think anyone at Iddybon was using Scala at all. But enter Michelle, and I was really excited about it. And I think we ended up releasing a platform, IDML, which I don't think is alive anymore. But that was all Scala-based. And one of the first talks that I ever gave publicly was at Chris's meetup, and it was all about using Scala for machine learning. Iddybon was a machine learning models as a service company. And so when I moved to another startup, of course, follow the same pattern from before. Of course, I'm going to use Scala to build these machine learning products. And it worked pretty well, but I wasn't on AWS, so I was using GCP. And I tried to sort of hand that over to the engineering team. I had Dockerized this really neat classifier, tried to hand it over, and they're like, this is not a jar. I don't know what to do with this. This is not going to work. And so that's how I discovered GKE. So it turns out that Kubernetes works really, really well for deploying machine learning models, even if they're in Scala. And we ended up moving all of the Scala code into Kubernetes. And it just really transformed everything to see a machine learning application alongside the rest of a sort of traditional application. And so fast forward to joining Google in my second week, I'm still in orientation, and I find this team who had just launched this Kubeflow thing, and it was essentially building machine learning, building a framework for machine learning applications on Kubernetes, and that really spoke to me. But Google is very heavy on Python, and so I'm sort of bringing Scala into that world. But there's a lot of Python around me, so it's kind of a strange place to be. But there are many opinions. I still think that Scala is very much a valid way of deploying machine learning models. It's not necessarily a first-class citizen on Kubeflow, but PRs are accepted. If anyone really wants to contribute, I will absolutely support you in that.
Any volunteers?
Is this the part where we start fighting on the panel?
Okay, so Pete, just to call him out, before the panel started, I think he said that you thought that in ML, software best practices are no longer relevant. Do you want to?
Okay, cue the tweet war happening in the back channel. So I think, okay, we're going there. All right, so I think I've heard that said in different ways. So there was a great talk. So the chief scientist or lead scientist at Uber, Karpathy, gave a great talk where he's talking about software engineering 2.0. And
He's at Tesla.
Oh, I'm sorry, Tesla. So many self-driving car startups, it's hard to keep them straight. So anyway, so the interesting thing there is that a lot of the things that he was talking about were things that I think Facebook and Google and LinkedIn hit many years ago. and struggled with, but it was such a small pocket of folks doing AI, and obviously Microsoft and Amazon very early as well, applying AI at scale and AI and machine learning used interchangeably here. And software engineering things like unit testing and agile and stand-ups and things like that really start breaking down, I think, when you're working on machine learning and AI projects. And some of the friction could be attributed to, okay, data scientists or machine learning researchers are hard to work with and they want to write papers and things like that. But I think that's only part of it. The other part of it is that the fundamental problems that you're working on are structured very differently. It's not like you're an architect or astronaut where you can plan out what things are going to look like 12 months ahead and know in detail how it's going to work and then be right if you're a really good software engineering manager. With this stuff, you often don't know, even for problems that look almost identical to ones you solved before. When you try it on a different data set or a subtly different problem, it doesn't work at all. And that's for the problems that you think you understand. And so that makes all these things very difficult. The data is changing underneath you. There's a lot of people talking about data pipelines and streaming real-time data. Real-time data is great, but guess what? Like, how are you going to unit test that? When your data is fundamentally shifting. This is how, for example, one of the reasons, not the only reason why, Facebook and folks can be caught unaware of these new adversarial tactics and their machine learning algorithms can't catch bad actors, right? Because people are changing underneath you while you're building the model.
I feel like Chris and Stepan, you might want to jump in and disagree, or you both offer sort of services that help with this, right?
So back to the question about the Scala and Python. Sorry, I have an opinion here. Yeah.
I thought that's what you wanted to do.
Okay, come on, guys. It is 2019 already, like 2018. We have we tend to build layers. We tend to build microservices. We tend to diversify our stack between different languages and paradigms. So it's absolutely okay to use Java, Scala for middle layers, for any orchestration stuff, and use Python for some user-specific DSLs. And if data scientists love Python, nothing bad with this. So let's follow this trend and provide more Python-based libraries for data scientists to use it. So it's nothing. You've seen like Salesforce has open source transmogrify. Yeah.
Not my choice.
Yeah. Yeah. So I believe it will find its niche. It will find its users. It's a good it's a great product. So, but it's probably, I'm not sure, maybe 1% of the data scientists would change their stack towards Scala, even if it's great to know. Back to the question about the best practices. The first, unit tests. If you can think about how unit tests are being implemented in machine learning way, so machine learning writes the code for itself, and the way to write a unit test is machine learning testing and training. Basically, the training procedure is reinvented the way we write tests. And if as a software engineers we will think about this, we don't need to write explicit tests right now. We should use just data to write the tests for us in a new way, in a new software 2.0 stack. The same way how we write the tests, but the difference is on a classical software, once you wrote your tests, and if they pass, you kind of 100% or 90% aware of that will work in production. The same way you tested it, you pushed it to production, it will work forever. In a machine learning way, you should run those tests continuously, even in production, because your data is being changed and your tests are being changed as well. So it's kind of, and this is another way for writing these tests. It's kind of probabilistic asserts. Yeah, You can't write explicit asserts. You can't write like type safe asserts there. It's like probabilistic way to write those tests. It's a new way of thinking about this. So just a thought.
Yeah, so I'm gonna say, so I somewhat disagree with you, Pete, that like traditional software engineering practices don't work on machine learning. So I feel like you just need the right framework for doing that. So I agree that the tools don't exist yet, but I think the way you build them is to take the concepts from traditional software engineering practices and apply those to the domain of machine learning. So it's not, the solution isn't going to look the same, but I think we can sort of bootstrap what those frameworks look like by using some of the existing tools and then building out where it doesn't exist. And that is kind of the concept behind Kubeflow, is taking a lot of those, trying to distill out the things that do apply to machine learning and then build something very specific that fills in that gap.
Chris, you have a...
Hello. Yes, I have a couple questions for you, Lucas. What's the relationship between figure 8, like Crowdflower, and weights and biases? Because I get 3 different answers with like 3 different people. So so it was first Crowdflower, then it was renamed to figure 8?
Yep.
Okay. And then you went off and started weights and biases?
Yep, exactly right.
Okay.
Thanks.
Yes, we could talk about that offline.
And you should buy all 3 of these services.
Yeah. We ran across Crowdflower. Yeah, so we have a way, because like Pipeline is the runtime for like all predictions, we're able to actually detect unconfident predictions and send them off. And then right now we send them to a Slack channel. And then, yeah, we've been opening up the Slack channel to Crowdflower folks or like Mechanical Turk. So I didn't
Hopefully
quite...
not Mechanical Turk.
Yeah. Well, I don't quite know where this conversation was going, so I'm just going to talk about what I want to talk about. But
Thanks. You're really helping me with this moderation job. Yeah. Sort of it. Yeah.
I mean, I think everything's been said over there, right? So we're seeing a lot. It's funny because a few years ago, I was at Netflix, and the head of data science was very skeptical of Spark and very skeptical of the JVM. And yeah, like his name is Xavier yeah, I don't know. He's at, I think he just went to a healthcare company, but yeah, he went to Quora afterward. So he's famous for saying that like you don't even really need Spark. Just rewrite everything in C. Take the existing models that you have, because that's all that's happening anyway, right? SciPy, like NumPy, all these are just going down to C. TensorFlow is going down to C. So they were able to reduce their cluster from like a 15-node Spark cluster to like one single node, which was huge cost savings. Just one big gigantic node. So that's the kind of stuff we're seeing.
Cool. Do you want to just pitch your company?
I'm not going to go there for the sake of this panel and our audience, which I still would love to hear audience questions. I think in terms of our stack, we use a lot of PyTorch in research, and then PyTorch 1.0 just came out, which is great. So now it has also serving capabilities, and so maybe, hopefully, PyTorch will be able to eventually be the one unifying framework for both the researchers and the engineers.
So at this point, does the audience have any questions? I have a whole bunch more, but
Got one back
we
there.
got one. Nice.
So can you please elaborate on rewrite everything in C++ and we don't need Spark? Just repeat the question.
Yeah, the question is about, so it's a pretty famous blog post. Yeah, his name is Xavier, Xavier, and then something. Just search that, Netflix. And I think it was like an ALS implementation or something. So it took the developer, 4 days to get to that performance, but 4 days of developer time, and then you save 15 nodes, through the rest of the the training life of that model. So these are very specific cases, right? But I guess in the context of which languages, this isn't a C++ conference, but we don't really see much Scala, honestly. I think last year I did a Python talk here, and I got yelled at by Alexi. So I tried to squeeze in a little bit of Scala in there, but who's the guy out of Brussels what's his name? I can't think of it now. Famous guy, created the Spark notebook, and eventually couldn't really get enough traction, couldn't get people off of Python in the data science world. So.
Yeah, I was going to chime in on that. So I didn't answer the Python Scala question.
I didn't know it'd be so popular.
Yeah. So I don't remember. There was somebody on Twitter said something controversial a few weeks ago, as they normally do. But it was something about, so how's that Python versus R war going? You know, kind of jokingly, in that realistically Python won, right? So Python has won that war, and I think if you take a poll of most machine learning folks, actually you don't have to. So the creator of Keras has a great chart where he mined Hacker News job postings, for example, and he looked at, you know, what are the trends, what are the keywords, and a lot of them were, you know, PyTorch, Keras, a lot more PyTorch actually than TensorFlow. Sorry, Google, for a lot of the startups and academics. Okay, yes, Kubeflow supports both. So that was a trend. And the other trend was, if you looked at all the technologies, almost all of them, they were all Python-based. And so for machine learning and AI, both in academia and in startups and increasingly in large companies, they're using, you know, PyTorch and TensorFlow and Keras.
I think, question?
Do you think that tools like PySpark can narrow this gap? Like Python API using JVM backend can narrow this gap between like people who love Python but still have like this JVM?
I mean, I don't know if you've ever used PySpark, but like trying to debug that extra layer is horrible. Like the theory is solid, but it's hard.
I think this also comes from two very different worlds. So if you take a tool and you try to make it do something it wasn't originally designed to do, it can be a big problem. So these other tools were built ground up by, you know, Jan LeCun and crew and folks who have been doing this for 20 years, doing essentially, you know, neural networks, versus, this is my opinion, Spark, I think, worked really well for a lot of analytics workflows. And we tried to use Spark at our startup at one point and use PySpark. And the community seemed to be overloaded and burdened with all these issues and bugs. And when it came to like deep learning or anything related to that, they were not being resolved, right? And so for us, it just felt like they were really good at resolving things having to do with streaming data and analytics, but not so good on the AI stuff.
I would add, so Spark is not about machine learning at all. So they have Spark ML, but I believe that machine learning stuff has to be decoupled from the data processing stuff. So it should be a separated data processing independent library to be used for machine learning. So,
Richard, I'm really genuinely curious. Could you walk us through how you decided to go with PyTorch over the other frameworks?
I'm not a big believer in research to force people onto a tool because in the end, at least in the very beginning of modeling research, it's much more about the ideas and how quickly you can iterate on them. And so at the same time, when you have something that really worked and then you're trying to get it into production and everybody has like a different framework, that is kind of annoying. And so I was happy to have seen a natural tendency. So we started with Chainer, C, some crazy people who tried to do that and were slow at iterating, but fast once they were done iterating. And Chainer back then, and Theano actually back in the day even. But long story short, it all merged. We had some experts in PyTorch in the group, and they were able to convince everybody. And once you look at some nice, clean PyTorch code, it won also the war against TensorFlow. Not really war, but discussions and so on. Because in the end, I think TensorFlow and most other libraries other than PyTorch really pull you back into the convex hull of known models. So if you want to just take an existing, recurrent neural network sequence model and just run it on some data and go really large scale, then yeah, you can use a lot of different standard tools. But in research, once you want to develop some new model that maybe adds reinforcement learning and has a memory component in your NLP model and it's a deep complex neural network with some crazy pointer mechanisms and whatnot, then you just can't do that in any other framework other than PyTorch, and still iterate quickly through that. So for research, it's quite obvious what the right tool was for the group. And then, of course, the problem is now that once you figured it out, like trying to make it work in TensorFlow is then another group, and because nothing ever ends, right? Data changes, but the models also keep improving quite rapidly. It becomes a really annoying cat and mouse game between two groups of like, oh, we're finally figured out, like we're finally able to replicate your research model from PyTorch in this other framework. And then they're like, oh yeah, but that was last month and we already improved it, and here are 5 more tweaks, and they're like, oh, now we have to do that to get the higher accuracy. And so, long story short, it would be great to push PyTorch and have more PyTorch serving infrastructure.
And not to get too inside baseball, but Chris, are you seeing the same trend, or?
Yeah, I mean, we tend to see quite a bit of TensorFlow just, because that's the group that we've been rolling with. My question about PyTorch.
I mean, the group that you've been rolling with.
So for like PyTorch for the inference, is it still Onyx and all that stuff? Is that what they're pushing, or like there's a native?
We just so Onyx is really great in theory, but it just has not gotten enough support, and we tried to use it and it didn't support like recurrent neural nets. And I was like, okay, that's the end of that. You could only use it for computer vision in the beginning, and they're making progress, but it's still slow, and I don't think it gets enough support so far. So when we serve PyTorch at all, it's usually in native PyTorch, or we just replicate the whole model in TensorFlow manually.
Do you have a question?
Wait. So now this is very important, right? So running it in PyTorch, right? So just, it's like behind like a Flask app then, right? Then calling, yeah. So like that's where things break down. And then to get the performance, you have to convert it into TensorFlow and then use TensorFlow serving.
Yeah, because TensorFlow serving just has all this nice infrastructure for engineering teams. And PyTorch did not have it until 1.0 came out quite recently. So now things might change.
Gotcha.
Cool.
Yeah, so I think it's really important to be iterating on your models in the same language that you're serving them in. And so like any sort of integration points, any sort of touch points, that's where things break down. And that is one of the biggest sources for the conflict between data science and engineering. And like, if you want to solve that, you provide a framework that gives you the workflow so that research is happy and engineering is happy and everyone's kind of all on the same team and there's no like throwing things over the fence. Like you want data scientists to have access to be able to iterate on their models and then push it directly to production. Like you don't want them to have to ask permission to deploy models. And from the other side of the fence, like you don't want DevOps having things thrown on their desk and like having an extra task. You really want to automate as much of that so that you can empower people at every stage of the app development process.
Well said.
Did you have a question? Sorry.
Yeah, I was just saying, you guys talked about making a lot of when you have to do real-time decisions, how do you actually approach that?
Please repeat the question.
I think you said when you have to make real-time decisions with performance bounds, how do you deal with that?
Yeah, and so that's why we like TensorFlow, and it's more than just the software layer. So we're actually working with these 2 hardware manufacturers that are targeting TensorFlow specifically, right? And so these are like TPU-like chips, basically, right? They're specific for deep learning. And they've been basically delaying their hardware launch to make sure that they're compliant with the I think it's the XLA like layer, right? That's below TensorFlow. That's sort of the intermediate representation between the C layer and the hardware, the kind of last mile. So once you start seeing these like hardware manufacturers paying attention to specific frameworks, this is kind of a sign that this is going to stick around. So
I think that's a really interesting question in that what often happens, so you do have this friction in this interface between research or prototype and then what's deployed in production. Actually, the genesis back at LinkedIn of the data scientist title, so Facebook and LinkedIn around the same time started calling people data scientists. The original intent is not what it is now, which means a lot of different things. It's like computer scientist, doing a lot of different things. The original intent was actually just that, what you said, Michelle, that we should be using the same language, using the same code base. Machine learning folks and research scientists should be pushing to production. And so that was the way that we ran things. Over time, now you have data scientists using Excel and whatever else. But that was the original intent, and we wanted it to be distinct from just research scientists. And the idea is research scientists were more focused on writing papers and didn't have to worry about maintaining things in production. In terms of scaling, and isn't that a concern if you're using some of these other tools. I think it's definitely an issue. I think in any custom machine learning model, you hit these edges pretty quickly. So you said, okay, the persistence doesn't support recurrent networks. You'll hit something like that. Another issue that we hit, embeddings, right? So there's amazing things that you can do with like word embeddings and entity embeddings, and Salesforce has done some really amazing stuff. But then if you need to serve an answer in real time in production or on mobile, right, on edge computing or on mobile devices, and I know Lucas, you've done a bunch of things thinking about mobile and small devices, then you hit these problems of memory constraints, right? And how do you squeeze, terabytes of embedding data and have it available in memory for these machine learning models? And so one thing I'd call out there that's kind of interesting is a startup called Rockset. So from ex-Facebook folks, we use some similar technology in our startup for doing conversational AI, and we squeezed embeddings into essentially RocksDB-based system, and that way you could store large amounts of data and access it in real time.
I just want to do a quick check because it's got super technical. I'm trying to read the audience. Like, how many folks actually work on like projects involving machine learning in their day jobs? Okay, cool. Big fraction of you. Awesome. Did you have a question?
Yeah, so I guess we're on the topic of TensorFlow and PyTorch. It's kind of interesting to see both of them coming towards each other in the opposite directions. What do you guys think of that? I mean, we have AI 2.0 coming out with easy execution, even though they had easy execution for that, and PyTorch now coming out with production. How does that fit in from the way to pushing research models into production without limitations?
I mean, it's just obviously great. And I think the question is, how do we feel about PyTorch and TensorFlow coming closer and closer to one another, and PyTorch having more serving capabilities, TensorFlow having eager execution, and so on. And I think it's just obviously great. And if I was to work in programming languages, I would probably think about the next generation of deep learning and the 2.0 kind of stack, because there's still a lot of interesting research that can be done in creating programming frameworks like PyTorch and TensorFlow that make it easier and easier and lower the bar to, for instance, have connections to graphical models and have hidden variables, and think about sampling and integrating RL, and having enough flexibility still, like PyTorch does, to even come up with completely new things.
Right, like you should also realize too that Spark is becoming more like TensorFlow, and TensorFlow is trying to become more like Spark, right? So TensorFlow has the dataset API, which basically at that point you pretty much don't even need Spark anymore, right? Which I'm a big fan of, trying to get rid of, just like simplifying the stack, right? But yeah, so there's actually 3 frameworks that are coming together.
And actually, it's a bit more than just frameworks. It's politics behind every framework. The company who drives that framework, I'm not sure they can converge into the single one. So,
Michelle, do you have thoughts on this?
I mean, I think it's great that, so the closer they come together, the easier it is to support them both. The last Kubeflow release was to have API parity between TensorFlow and PyTorch, and as a platform developer, that makes a lot of sense. That makes things easier. It makes things easier for developing on top of a platform. But ultimately, I think, so the concept behind building a platform that will support any framework you throw at it, that's most important, because TensorFlow and PyTorch are really popular now, but who knows what's coming tomorrow? It may be the platform of the future that combines the best of both worlds, who knows? But it's about building resilient applications that are loosely coupled microservices so that you can easily slot in something else. So I think it's good that they're coming together, but it's not something that I'm going to bank on.
So Alexi, how are we doing? Is this too inside baseball, too technical, or you like it? All right. Awesome. More questions? So one of the things that we were talking about kind of, before we started this panel that I thought was pretty interesting was, kind of what tools, if you're, an average software company today, and I'm sure you guys have thoughts here, what what tools should you be like buying or looking in open source for, and like what should you be kind of building in-house? Like what part of your, like should you even be trying to train your own models if that's not the core thing that your company does?
It's a super interesting question. I actually think when we have a lot of companies that reach out to us and they want to do something with AI, and then I ask, where's your data? And the first thing they say is like, well, it's in a bunch of different places. So that's one issue. And so the data pipelines is, and has been mentioned here before, is a big thing. But then once you have it all pipelined, you still often need to label it. And I know you've worked on this a lot, and you've done a lot of, you've made a lot of progress in this. And I see a lot of other startups working in that space too, and you have big players like Amazon Mechanical Turk, but it's still not really figured out how to really make data labeling as like part of a simple pipeline where it's low touch. Like you're just like, here's the description of what I want. Just give me like 10,000 really cleanly labeled examples of that, and like it'll just work. Like you still have to do implement a bunch of checks and so on. So making that, and then there's so many special cases, right? Maybe you have 3D LiDAR data and you want to connect that to 2D image data, and then you have time series, or you have videos, you have language and different languages, different natural languages and so on. So there's still so much complexity that nobody has figured out that piece really well. And I think as startups, there's still space to make progress, but then it's also a slow sort of slog to get enterprise customers to adopt your pipeline and so on. And then the question is, should large companies have that themselves? Like Google spends a lot of money for really important search kinds of results on manual labeling themselves. And so as a big company, should you rely on an outside tool or company, or should you try to build it yourself when it's a recurring thing that keeps happening and you keep getting more and more data that needs to label like new products and images of new products? And you'll never be done with categorizing all products, because there will always be new ones coming out. And so when you think that there is a recurring kind of data labeling question, like how much can you rely on outside vendors, and the cost and all of that. So that's one of the many thoughts I have on that question.
Yeah, I think one decision that really makes or breaks a team is if you use Airflow or some kind of like orchestration. I guess that's orchestration, or workflow kind of thing. People, a couple of years ago, I think Airflow was the obvious choice. I know Kubeflow uses Argo. I don't know a single person that actually uses Argo outside of when they're trying Kubeflow, but yeah, like we can talk about that offline. But do you? Okay. But I think that's an important one, right? Because if you don't have clear visibility, and if you're trying to write these things, I actually had a call this morning with a customer in Germany, and they're using Uzi, and it's a question I didn't even ask when we started working with them, and then I was like, oh fuck, how are we gonna integrate with Uzi? Does this thing even work anymore? And it's all XML, and it's just horrible. But yeah, so I think that's an important choice.
Yeah, about tooling, ML tooling. It's a completely wild space, and I have even a T-shirt. It's a ML in a shell. So you need to give a shell to ML engineer to be ready to iterate, to develop, and push things to production, to label data quickly and reliably, and then have all that orchestration workflow managed all together. So the tooling space is just one new crazy area to be investing into. The question is either you want to build it internally as an engineers. Of course, we all have our own engineering ego to build something interesting. Because building a system things are much more interesting than for engineers, at least, rather than implementing a business logic and talking to business maybe. So tooling, all kind of tooling. But for my experience, it's even hard to see the companies that go beyond having an inventory of your Jupyter notebooks with the pre-installed dependencies that will satisfy all the needs of your data science teams. even having this like a very simple stuff, you have a Docker containers with Jupyter notebooks and you have kind of inventory that you can run Jupyter notebooks with TensorFlow dependencies to do your research there. You have a notebook or like Zeppelin notebook with the Spark dependencies and all that stuff. It's very basic thing, but it's missing in most of the companies I see so far.
I mean, my advice is always, if there is a hosted managed version of something, use it. If you build your architecture in such a way that you can, if it's these loosely coupled microservices, you can change those components out later, but the fastest way to build something useful is to use the managed version. And the way you sort of insulate from the lock-in that can bring is to use managed versions of open source products. That way you can also swap out the underlying infrastructure. I think I've seen that be successful for so many people, and that's why I'm so involved in open source, because I think that really benefits everyone, vendors and engineers alike.
Yeah, I think this is a really politically loaded question in many companies, because everybody wants to work on cool problems, and if you're lower in the stack, you want to build your own infrastructure. If you're an AI person, you want to train the model to do the cool image recognition thing, even if Facebook and Google have orders of magnitude more data and can build a better model for sure than you can. And so I think this is where it's on the leaders in the organization and folks probably in this room to step back and make some of these tough calls, right? So one way to think about it is what is your competitive advantage? There's a great talk actually by the CEO of ServiceNow talking about this back at eBay years ago, and then how he's thinking about it at ServiceNow. And he was saying, for the things we were building, there were plenty of things. It wasn't going to be our competitive advantage. That was not what people went to eBay for. So you should focus on those things. Maybe it's like Richard was saying, the specific data elements that you have that Google doesn't, and double down on your models for that. But it could also be, like infrastructure. Maybe you should use Google hosted stuff. Use Amazon, right? It used to be nobody went broke buying IBM. Now it's nobody went broke buying GCP or AWS, right? So I think you have to make a strong case to do something different right now for many of those. And then the other interesting area, which is just emerging now, is we definitely have these problems in the development flow and life cycle for building AI and ML products. And I think what's going to emerge are these narrow companies like Weights and Biases. Like I just saw an interesting company that's rethinking testing for machine learning and doing these probabilistic tests on logs. There's going to be this suite of startups that you can plug in. So think of it like a new LAMP stack, right? But this time I don't think it'll be open source. It may be partially open source. It'll be like a figure eight, weights and biases, and you take 4 or 5 of these things and plug them together, and that'll get you 80% of the way there. And guess what? It's running on GCP or AWS.
Yeah, we're gonna get integrated with weights and biases and figure eight. That's and Kubeflow with everything.
Yeah, I hear weights and biases will be integrated with Kubeflow very shortly.
And then PyTorch for everything else. Right?
Sorry, did you have a question? Ooh, that's a really good question.
Yeah. And I think Richard and I probably have hit this hard.
Yeah, sorry, the question was, I hope I paraphrased this right, is there like an inherent difference between sort of the B2B machine learning applications like a bank might do versus sort of like B2C applications like Facebook might do?
Boy, where to start? Yeah, there are a lot of things. So
is happy hour starting yet?
Yeah. I think explainability, if you're in banking and you make some pretty fundamental decisions about people's lives, should they get a loan to start a business? Should you pay for their, insurance or their car damage, and it could bankrupt them if you don't. And so I think the bar is kind of higher to make some of those decisions correctly. And often machine learning falls on sort of a precision and recall trade-off curve. You might not want to make all your decisions automatically. have lower recall, but you may want to, the decisions that you do make, you need to be really, really precise. Whereas like in Google, for instance, it's okay if like not the first result is the right result, but as long as you have the high recall, precision can be a little bit lower. If you don't click on every single ad, which of course nobody does, like that's okay. But if as long as you click on some of the ads some of the time. So precision versus recall is, I think, one way you can put this trade-off. And of course, in enterprise, enterprise is a big space, so there are lots of different things in it, and they fall into different parts of that curve. And then I think explainability is crucial when you want to change human behavior. You can't just ask like salespeople who've done their job for like 20 years to like go and call this person instead of sending an email to that other organization. And they're like, well, I've been doing my job for 20 years. Why is this AI telling me something? So for those areas where you want to change human behavior, you need to give explainability to it too. And then of course the big and obvious one is you don't actually have the size that Google has for most enterprise applications. Most companies don't need to have like 1,000 GPU machines, each with like 8 P100s in them to train on all of the images that come up on the internet, right? They have maybe 2,000 different products, and they have 2 pictures of each product, and now you have this odd combination of high D, low N kind of thing, where you actually have few training examples for each category, and now you still want to do something with that kind of data set. And so I could go on forever, but those are sort of the main things. The trust that comes with enterprise data is a pretty crucial piece. You can't really, Facebook lost millions of people's data. If you do that as an enterprise, you're dead. You just can't afford that.
So I've been kind of selling machine learning services to companies for a long time, and one of the big changes that I've seen, I think, I hadn't quite exactly thought about this until you asked the question, but when we started 10, 15 years ago, almost all the applications were B2C. It was sort of like ad ranking and like search, and it was like all around things that sort of increased revenue for B2C companies. Basically, was where you saw machine learning applications. And I think B2B's taken longer for like some of the things that's what you're saying, right? The precision recall trade-off is different, right? It's like it's maybe more dangerous to make a mistake, and maybe because in a B2B context, you're often sort of saving money versus like making more money, and I think companies tend to be less excited about that. But that said, I think that one of the big trends I've seen in the last 2-3 years that I think has been part of this explosion in machine learning has been, I think these days every B2B company is thinking how do I apply, especially Salesforce, right? Thinking, how do I apply machine learning to all the back office and all the business process stuff that I do. And I think there is something you can do in B2B that I think is kind of underused, a kind of design pattern that we call human in the loop, where you don't have to solve every single case, right? So if you're serving up search results, you can't just be like, okay, this one's too hard, the machine learning is confused, we're not going to give you a result, right? But if you're trying to say, should I flag these sales records as entered incorrectly? You could say, the algorithm's not sure about these ones. Let's send these to a human operator to deal with, and the rest the algorithm takes.
Yeah, so keep in mind too that you guys have choices where you work, and so growing up in Chicago, I was in the whole fintech, the insurance, just hell, right? And then I come to Netflix, and I'm like, oh wait, I actually had a choice this whole time, and it's way more fun to work for a company that's not worrying so much about the explainability and each transaction going through and every penny being accounted for. That's just boring,
Well, so I think there's something else that circles back to the beginning of the discussion where we're talking about this intersection of data engineering and AI. And there's a great Monica Rigatti, who's somebody a few of us know, worked with her back at LinkedIn, data science. She has this great data science hierarchy of needs of all the things you need before at the pinnacle of self-actualization, you hit AI. And a lot of it is like plumbing, right? And so when I talk to a lot of enterprise companies that say, hey, we want to do AI, the people who are doing AI early, like Google and other folks, they were trying to solve certain problems and they said, oh, this is the right way to do it. Now what you have is a situation where people saw this great success and all the gains that they had at Facebook and Google, et cetera, and they say, we want some of that, right? And then when you go in and talk to them, a lot of these companies lacked the infrastructure. And if you think about it, it makes sense. So if you're Google and you're optimizing page load time, and they squeeze out every fraction for ads and everything, and it matters, everything is tracked in excruciating detail. And that's kind of what you need for AI to work, right? You need a sensory system that's recording all the data so the robot arm can move around. When you go into a lot of these environments that are more B2B, they never needed to do that, right? So now I think the race is, for people in this room, you need to catch all these companies up and give them that nervous system of data that they need with tracking and search. You need to track impressions and clicks and all these things. And then you can apply the cool, machine learning and deep learning.
Yeah, I would add, so we are on Scale, by the way, conference. So scale means different things for AI. For some people, scale is a scale in terms of high load and low latency, like Google. For some for companies like Salesforce, scale is a huge multi-tenancy scale across all the tenants and managing the AI applications across highly compliant tenants. For others, like scale is a scale of training process. For us, scale of managing the multiple, like hundreds of models in production and monitoring those models in production. For folks like Kubeflow team, it's probably a scale of managing the workflow across enterprise, across companies. How would you and people involved into this AI process and AI development process of the applications. So it's AI is very, very different in terms of the customers of this.
And maybe to point out the opposite of that, which is, yes, that's true, but it's also the opposite is true in that a lot of companies are also, they have their own end consumers. And so now for us, we don't just think as B2B as one business to another business, but we're thinking about the whole B2B2C. So we also offer marketing solutions, and we have to go through all Twitter, like we have access to the full Twitter fire hose, and we need to deal with that every second too. So it's like, that's fully in the same world as in others. We have IoT signals where we get robot arms to send us like millions and millions of IoT signals every second or minute, and so we need to deal with those and find anomalies in them and all of that. So I think the worlds are also sometimes merging between the two, but enterprise certainly has some of its own unique challenges.
So is Salesforce going to become Skynet? Is that
Hopefully.
So that's a super cool.
One quick thing. I think Pete said something really important about the hierarchy, that in order to do AI, you need good data, but don't mistake having good data with having good data infrastructure. Like there's a large foundation that you need before it makes sense for you to do AI. If anyone was in David's talk, David from Sumo Logic, I think it was yesterday, I steal his slide in like every talk I give, because he basically makes the point that if you can do it in a deterministic way, you should do it. Like do not use ML if you don't have good data and good data infrastructure.
Well, let's continue this conversation over drinks, yeah? Thank you.
Thank you.
Thank you, guys. That was a great panel.